Good morning, everyone. Welcome to the class on duality in linear programming. So, I believe in our journey to learn linear programming approach, how to solve the linear programming approach, we have learned a lot of events. We have learned a lot of ways to solve an LPP problem. First, we learned how to construct an equation from the given data. If a given problem is given to us, then we learn how to formulate an LPP equation. And once we learned how to formulate an LPP equation, then we learned how to solve that equation by using a graphical method or by using simplex method. Okay, so we learned how to solve them. So either you apply graphical method or either you apply simplex method or either you apply solver in MS Excel. By using all these methods, you can actually find the values solution. They give the values of the solutions you can easily find. Okay, so once you find the values of the given problem, once there's a problem and you find the values of the given problem, you can understand how important is that value. So working on linear programming has actually made us to understand the real life event. So the real life event cannot work on LHS equal to RHS. It can be much varies from LHS equal to RHS. It is totally based on inequality. So now the question comes, why in that scenario, why we need to learn the concept of duality. So the concept of duality is basically is just a replica. This concept of duality, when we try to learn, it is just a replica of a given problem. So the given problem, whatever the given problem we have, whatever the given problem we have, suppose our given problem is maxima of z is equal to x1 plus 2x2 plus x3. Suppose this is your equation subject to constraint. Subject to constraint, you have constraint like 2x1 plus x2 minus x3. This is less than or equal to 2. Then if I ask you minus 2x1 minus 2x1 plus x2 minus 5x3, okay, then it is greater than or equal to minus 6. And then you have 4x1 plus x2 plus x3. 4x1 plus x2 plus x3 is less than or equal to 6. And then you have x1, x2, x3 greater than or equal to 0. Suppose if this is a problem. So every problem, what we see, every LPP problem, what we can see, we call every LPP problem as a primal. So every LPP problem, what we see, which we call as a primal. So every LPP problem, what we see, which we call as a primal, it can be transformed into dual. So every LPP problem, what you see, which we called as a primal. So I can transform this into dual. So I can transform this LPP problem into dual. So dual is just a of the same problem, the another approach of solving the same problem. So the another approach, if we try to use to solve the given problem, the solution what you get by solving this problem, your x1, x2, x3, the same solution you will get simply by converting the problem into a dual form. That how the concept of duality comes. Now the question comes, why you need to convert that into dual form? Okay, you say, okay, you have to convert, well and good, you can convert. So primal you can convert into dual, you can do that. But the question comes, what is the need of doing it? So the need, why we need to do it, imagine the primal contain large number of constraints. If you have too many constraints and you have very smaller number of decision variables, sometime in the given LPP equation, sometime when we have given LPP equation, imagine if the primal contain, imagine the primal means this equation. Imagine the primal has lot of constraint. Suppose a primal have lot of constraint. So you know the reason. No? If you have lot of constraint, then what will happen? If you have lot of constraint, then you have to introduce that many number of slack variable, negative or positive. You need to introduce that many number of slack variable. So once you introduce that many number of slack variable, then altogether you remember by using simplex method and all, if you introduce that many number of slack variable, and then if you start solving the problem by introducing those variables into the given equation, then altogether you know that how much the problem can become complicated. So imagine if your primal has lot of constraint, okay, or it may have very small number of decision variable, or small number of decision variable, or it may have small number of decision variable, or it may have small number of decision variable. Okay, so under this scenario, what happened? Your mechanism of solving the problem will be cumbersome mechanism. So what you can do, the same problem you can look into dual form. So you can transform the same problem into dual form. Okay, how to transform the given problem to dual form? So before you try to transform the given problem to dual form, so before transforming the problem, the given primal, before transforming the given primal, before transforming the given primal into its dual form, before transforming it given problem into dual form, before transforming it given primal into dual form. Okay, what you can understand, guys, before transforming the given primal into dual form, guys, what you need to understand, you need to make sure before transforming the given primal into dual form, we need to make sure we need to make sure that the we need to make sure that the problem we need to make sure that the problem is in canonical form. We need to make sure that the problem is in canonical form. We need to make sure that the problem is in canonical form. Canonical form means what, sir? Before you transform the given primal into dual, whenever you have a problem, normally this also question don't come in Bangalore City, frankly speaking. Simply I'm doing because there in the course I have to do. Otherwise, Bangalore City don't ask question based on this. So if you have a primal and you want to look, you are interested for a dual. Okay, you have a primal and you are interested for a dual. Okay, so before you convert the primal into dual, you need to make sure that your problem is presented or represented in the canonical form. What do you mean by canonical form, guys? Canonical form basically means that if your objective function is maxima, then your constraint should be less than or equal to. What is canonical form? Canonical form means that if the objective function is maxima, if the objective function is maxima, then your constraint should be, all constraints should be less than or equal to 1. All your constraints should be less than, if the given problem, you if the given problem is in, if the objective of given problem maxima, then all your constraints should be less than or equal to, while what do you mean by canonical form? It means that if the objective function is minima, it means that when the objective function is minima, in case if your objective function is minima, then all your constraint, then it should be greater than or equal to. It should be greater than or equal to. So this is what canonical form basically means, that if your objective function maxima, then all your constraints should be less than equal to. It means if your objective function minima, then all your constraints should be greater than or equal to. That is what the canonical form basically means. If you see in this equation, this objective function is maxima. This constraint is less than two. This constraint is less than equal to, but this constraint is greater than equal to. Are you getting? And so this is right now the problem. What is there in front of you? This is not in canonical form. To be present in the canonical form, the all your constraints should be less than or equal to if the objective function is maxima. While if the objective function is minima, then all your constraints should be greater than equal to. So I hope you people understood this. So here, if you see the problem here, if you see the problem, if your problem is given like this, if the problem is given like this, maxima of z is equal to 3x1 minus x2 plus x3. This is your objective function. This is your objective function subject to 4x1. Suppose this is 3 objective function is 3x1 minus x2 plus 3x3. Okay, or better, let me write down the same problem what I wrote before. Function is x1 plus 2x2 plus x3, and if your constraints are given to you, 2x1 plus x2 minus x3 is less than or equal to 2, is less than or equal to 2, then this is minus 2x1 plus x2 minus 5x3 is greater than equal to minus 6. Then 4x1 plus x2 plus x3 is less than or equal to 6, where your x1, x2, x3 is greater than or equal to 0. So if this is the problem, guys, now this is your primal, guys, this is your primal, guys, this is your primal. So this is your primal. So this primal, this is not in canonical form because the objective function is maxima, but this constraint is less than equal to, this is greater than equal to, this is less than equal to. I write in canonical form, if I write in canonical form, your primal in the canonical form, so if you write your primal in the canonical form, then your objective function will be maximum of z is equal to x1 plus 2x2 plus x3, then subject to the constraint, this is 2x1 plus x2 minus x3 less than or equal to 2, and you can write this as 2x1, change the sign, 2x1 minus x2 plus 5x2, change the sign, is less than or equal to 6. Multiply minus 1 with both the sides. Those who have a math background, they can understand what I'm trying to do here. To change the inequality sign, multiply minus 1 with both the sides. Then you have 4x1 plus x2 plus x3 that is less than or equal to 6. Where your x1, your x2, your x3 that is greater than or equal to 0. Clear everyone? Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? Okay, fine. So once you clear this, now guys, now I want to write this into dual form, the primal what I have. I want to write the dual form of the primal. So whenever you want to write the dual form of the primal. Okay, so you'll introduce a dual variable, some variable, dual variable, depending upon the number of constraint what you have. And guys, always remember when you write them in dual form, then your maxima objective function will transform into minima objective function. Okay, so the maxima, when you write them in dual form, if your minima objective function will become maxima, maxima objective function will become minima. Okay, everyone. So what you will do, depending upon the number of depending upon the number of constraint what you have. So I have three constraints. I introduce three dual variable. That variable, dual variable or whatever variable name doesn't matter. The decision variable for dual form. So here because three constraints are there, so I introduce three decision variable for the dual form. So how will you write what will be the coefficient of the objective function of the dual form that will be the RHS of the constraint of the primal form. So RHS of the constraint of the primal form will become the coefficient of the objective function of the dual form. So this will become 2W1 plus 6W2 plus W3. Suppose I introduce three decision variable for the dual form. Those are W1, W2, W3. Suppose I introduce three decision variable for the dual form. So ultimately your option will become 2W1 plus 6W2 plus 6W3. Okay, subject to where the RHS of the constraint of the primal form will become the coefficient of the objective function of the dual form, subject to constraint. So you have to write constraint, no? So the coefficient of constraint you take like this. You take this as a coefficient of constraint. So you will write 2W1 plus 2W2 plus 4W3. Now the objective function is minima, right? So the sign will be maxima sign. Canonical form greater than or equal to the coefficient of the objective function of the primal. Similarly you can take this. This is W1 minus W2 plus W3 that is greater than or equal to 2. Then this is minus W1 plus 5W2 plus W3. Again, see the coefficient of the object. See the coefficient of the objective function of the primal. So the coefficient of the objective function of the primal will become the RHS of the dual, and RHS of the primal will become the coefficient of objective function of primal. Clear? Anyone? Any doubt? This was Z, so you can write Z dash. And then you can write your W1, W2, W3 is greater than or equal to 0. Then you get another LPP equation. Now if you find the value of x1, x2, x3 here, and then if you find the value of W1, W2, W3 here, that will be same value. Clear? Anyone? Any doubt? Any question? So suppose if this is your primal, so if you see the objective function is maxima, so your constraint should be less than equal to, here your constraint is less than equal to, this is greater than equal to, so it's not in canonical form, this is less than equal to, So your primal, whatever is your primal, you need to make sure your primal is in canonical form. So the first thing you write your primal in the prime canonical form. So that would be maxima of z is equal to 3x1 minus x2 plus x3. Okay. So subject to constraint. So subject to the constraint. This is 4x1 minus x2. You see, guys, three variables are there, three decision variable. I can write this as 0x3, no problem. Less than equal to 8. This I can write minus 8x1 minus x2 minus 3x3 less than or equal to minus 12. Then this is 5x1 plus 0x2 minus 6x3 is less than or equal to 13. So where your x1, x2, x3 is greater than or equal to 0. Clear, everyone? So once you write them in canonical form, guys, now this is your primal. This is your primal in the canonical form. Now this is your primal in canonical form. If I want to see the dual form of this, so the maximum of objective function will become minima of z dash. So z dash simply because that was variable z. This I'm writing z dash. So this will be this. So your RHS of the primal, RHS of your primal will become the coefficient of objective function of dual. So this would be 8w1 minus 12w2 plus 13w3, where what are w1 w3, they are the decision variable, they are the decision variable of the object, they are decision variable of the dual form. Subject to, you'll write subject to, then what you will write, then you need to write the constraint, no? So write the constraint like this. So this will be 4w1 minus 8w2 plus 5w3. This is objective function minima. So use the sign greater than equal to, then greater than equal to, then what should be the RHS? RHS will be the coefficient of the objective function of the primary. Then you can write minus w1 minus w2 plus 0w3 is greater than or equal to minus 1. And then you can write 0w1 minus 3w2 minus 6w3 is greater than or equal to the greater than equal to the coefficient of the primal one, where you w1, w2, w3, they should be greater than equal to 0. Clear, everyone? So in many books and all, they have finished the question till here. Or if you want, you can write the same dual form like this. Your dual form is like minima of z dash is equal to 8w1 minus 12w2 plus 13w3. Then subject to, then you can write 4w1 minus 8w2 plus 5w3 greater than equal to 3. Then w1 plus w2 is less than or equal to 1. Then you can write the same thing, minus 3w2 minus 6w3 is greater than equal to 1, where w1, w2, w3 is greater than equal to 0. Clear everyone? Anyone, any doubt? See this, ask me if you have any question. Anyone, any doubt, any question? So this much guys from the today class. We'll continue discussion tomorrow. In case if I possible to get the class, let me know your free time tomorrow in afternoon or something if you have. Clear everyone? So this much from the today class. I'm ending the class. Anyone have any doubt, any question, any concern, any problem, any tension, anything which you like to discuss with me? Thank you everyone. I'll see you all in next class. Take care. Bye everyone.